It is 6:35 p.m. on Sunday, October 4th, 1992. The Bijlmermeer is a massive, densely populated neighborhood on the southeastern edge of Amsterdam. The architecture here is brutalist and monolithic. 10-story concrete apartment blocks stretch out in massive, interconnected hexagons, forming a concrete honeycomb against the fading Dutch sky. Martin, a 42-year-old architectural draftsman, lives on the 6th floor of the Groeneveen building. It's a cool, overcast evening. The windows are cracked open, letting in the damp autumn breeze. He is standing at his kitchen counter, wiping down a cutting board. The smell of roasting garlic and onions fills the small apartment. In the living room, his teenage son is watching television. It's the kind of quiet, unremarkable Sunday evening that plays out in millions of homes around the world. Then, the teacups on the drying rack begin to vibrate. It's subtle at first, just a low, resonant hum vibrating through the reinforced concrete of the floorboards. Martin pauses, the damp rag in his hand. He frowns. "Did you turn the heavy cycle on?" he calls out to his wife in the hallway. "No," she replies, her voice carrying a note of confusion. "The machine is empty." The vibration deepens. It stops being a sound and becomes a physical pressure in the room. The glass in the window panes begins to chatter in their frames. The water in the kitchen sink ripples. Martin steps toward the window. The noise outside is building into an ungodly mechanical scream. It sounds like a freight train is being dragged across the roof of the building. But it's not just loud, it's entirely wrong. It's an asymmetric, pulsing roar. He leans his forehead against the cold glass, looking up into the twilight. Suddenly, the sky darkens. A massive shadow eclipses the neighborhood. Martin's breath catches in his throat. Dropping out of the low cloud cover, less than 1,000 feet above the ground, is a Boeing 747. It is impossibly huge, a 330,000-pound leviathan of aluminum and steel. But it's not flying. It's falling. The aircraft is banked at a sickening, vertical 90-degree angle. The right wing is pointing straight down at the courtyard. The left wing is pointing straight up at the stars. Martin can clearly see the underside of the massive fuselage, the landing gear deployed, reaching out like the claws of a dying bird. And as the right wing plummets toward the roof of the apartment block next to his, Martin sees something that defies all logic. There are no engines on the right wing. Where two massive turbofans should be, there is only a jagged, violently torn nightmare of shredded metal trailing a mist of highly flammable aviation fuel into the evening air. Martin doesn't have time to scream. He doesn't have time to turn around. He doesn't even have time to blink. At 6:35 and 42 seconds, El Al Flight 1862 slams directly into the intersection of the Groeneveen and Klein-Kreutberg apartment buildings at 260 knots. The impact unleashes an explosion so violently massive it registers on seismographs across the country. 20,000 gallons of jet fuel instantly atomize and ignite, creating a 2,000-degree fireball that consumes the concrete structure, instantly vaporizing everything and everyone inside. To understand how a heavily modified cargo plane fell out of the sky and annihilated an apartment block, we cannot look at the pilots. We cannot even look at the maintenance crews at Schiphol Airport. To find the true villain of this story, we have to rewind the clock 24 years, and we have to look at a boardroom table thousands of miles away. We have to look at the mathematics of arrogance. Think about what it takes to build a monster. Let me paint a picture for you. It is the late 1960s in Seattle, Washington. The engineers at Boeing are attempting something that has never been done in the history of human aviation. They are designing the 747, the jumbo jet. It isn't just an airplane, it is a flying cruise ship. It's so massive, so heavy, that to get it off the ground, they need engines of unprecedented size and power. Enter the Pratt & Whitney JT9D high bypass turbofan. These engines are absolute behemoths. Each one weighs 8,600 pounds, nearly 4.5 tons of spinning titanium, compressor blades, and combustion chambers.
At takeoff, just one of these engines generates 47,000 pounds of thrust. Now place yourself in the engineering department. You have a massive wing filled with thousands of gallons of highly combustible aviation fuel. You need to hang a 4.5-ton engine underneath that wing. But there is a terrifying hypothetical that keeps the engineers awake at night. Look at the stress load on the aft mount, an engineer says, pointing to a sprawling blueprint spread across a drafting table. These engines run hot and they run hard. What happens if a fan blade fractures? What happens if the engine seizes up mid-flight? The rotational torque would be catastrophic, another engineer replies, tracing a pencil along the wing's internal spars. If a 9,000-pound engine suddenly locks up while spinning at thousands of RPMs, the vibration won't just shake the plane, it will physically rip the wing off the fuselage. Everybody dies. The men in the room stare at the blueprint. The math is undeniable. If an engine destroys itself, it will take the wing with it. Unless they build in a fail-safe. So we make the mount weaker, the project lead says, tapping the desk with his pen. We build in an intentional failure point, a fuse, just like the fuse box in your basement. If the electrical load gets too high, the fuse blows, the circuit breaks, and the house doesn't burn down. You want to build a fuse for a 4-ton jet engine? Exactly. We attach the engine pylon to the wing using hollow steel pins. If the engine seizes, the sudden spike in shear force will snap the pins cleanly. The engine drops away, the wing survives. The pilot flies home on 3 engines. And it just falls? The younger engineer asks, his brow furrowed. A 4-ton piece of machinery just falls from 30,000 feet? Better an engine in a farmer's field than 300 people in a fireball, the lead replies. This was the birth of the fuse pin. It sounds like a logical, life-saving piece of engineering, but it was built on a foundation of pure, unadulterated hubris. It was a bureaucratic calculation that looked perfect on paper, but completely ignored the chaotic, unpredictable violence of physics in the real world. The 747 engine pylon was secured to the wing by 4 of these fuse pins. They were essentially hollow cylinders machined from high-strength steel. The specific pin we need to focus on, the one that will eventually doom Flight 1862, is called the mid-spar fuse pin. Boeing's engineers calculated the exact amount of vertical shear force required to snap this hollow pin. They assumed that if an engine seized, it would pull straight down, breaking the pins cleanly and dropping away like a released bomb. They called it a clean break. But the engineers made a fatal oversight. They only calculated for vertical straight-line forces. They did not account for what would happen if the pin cracked slowly over time. They did not account for metal fatigue. And most importantly, they failed to realize that if an engine tore loose, the immense thrust it was still producing wouldn't just pull it down, it would violently twist it up and forward. Decades later, investigators would look at this design and realize it was a ticking time bomb. The walls of the mid-spar fuse pin were too thin. The machining process left microscopic burrs inside the hollow cylinder. And every time a 747 took off, every time those engines roared to life and pushed that colossal weight down the runway, invisible stress was applied to that steel. Year after year, flight after flight, the metal would heat up, cool down, expand, and contract. In a perfectly engineered system, those pins would last the lifetime of the aircraft. But the system wasn't perfect. By the early 1990s, inside the right wing of an LL cargo plane, a microscopic stress fracture had formed inside the inner bore of the mid-spar fuse pin on engine number 3. It was exactly 0.05 inches deep. It was invisible to the naked eye. It was completely undetectable by standard maintenance checks. But it was growing. Every time the massive cargo door of Flight 1862 slammed shut, every time the aircraft touched down in Tel Aviv, New York, or Amsterdam, that microscopic crack crept a fraction of a millimeter deeper into the steel. The fuse was slowly burning, and on a cool Sunday evening in October, That fuse was about to reach the powder keg. Think about the sheer scale of modern global logistics. We take it for granted. We order a product and 48 hours later, it arrives on our doorstep. But we rarely think about the invisible rivers of freight flowing directly over our heads, massive, aging machines carrying unimaginable payloads through the dark. Let me take you to the tarmac at Amsterdam's Schiphol Airport. It is the late afternoon of October 4th, 1992. The weather is standard for a Dutch autumn, 55 degrees Fahrenheit, overcast, a damp wind sweeping across the flat concrete apron of Ramp 8. Sitting under the halogen floodlights is a Boeing 747-258F, registered as 4X-AXG. This is not a sleek, new passenger jet. This is a 13-year-old, heavily scarred workhorse belonging to El Al, Israel's national airline. It has logged exactly 45,746 flight hours. It has endured over 10,000 pressurization cycles. Its aluminum skin is streaked with soot from the engine exhausts and stained with hydraulic fluid. It looks exactly like what it is, a 300,000-pound freighter built for punishment. Underneath the sprawling wings, the ground crew is swarming like ants around a dead leviathan. Scissor lifts whine as they raise massive aluminum cargo pallets up to the main deck's gaping side door. Stand near the nose gear for a moment. Look up at the cockpit windows 40 feet above the ground. Up there, in the right seat, sits flight engineer Gedalia Sofer. He is 61 years old, a veteran of the skies, with over 26,000 hours of flight time. He is a man who understands the machine around him not just as a vehicle, but as a living, breathing organism of pneumatics, electrical buses, and high-pressure hydraulics. Next to him is First Officer Arnon Ohad, 32 years old, meticulously running his finger down a laminated pre-flight checklist. And in the left seat, commanding the ship, is Captain Yitzhak Fuchs. Fuchs is 59, a former fighter pilot, a man whose resting pulse barely rises when an engine sputters. He is reviewing the cargo manifest handed to him by the Schiphol loadmaster. You can picture the exchange in the cramped, humid cockpit, the smell of ozone and old coffee lingering in the air. "Maximum zero fuel weight is looking tight, Captain," the loadmaster says, leaning against the bulkhead. He taps a clipboard with a grease pencil. "We're loading 114 tons of freight today, mostly consumer goods, textiles, some computer parts, standard routing to Tel Aviv." Captain Fuchs runs his thumb over the second page of the manifest. His eyes narrow slightly. "And the special handling cargo, positions 3 and 4? "Secured and netted," the loadmaster replies, lowering his voice just a fraction, out of habit more than necessity. "We've got 10 tons of chemicals back there. Industrial solvents mostly, but we double-strapped the pallets containing the DMMP. Captain Fuchs nods slowly. "Good. Make sure the load tensioners are locked tight. I don't want anything shifting if we hit turbulence over the Alps." What they are discussing, the DMMP, is dimethyl methylphosphonate. In the belly of this aging aircraft, directly beneath the floorboards where the crew sits, are 190 liters of this highly restricted Schedule II chemical. On paper, it's a flame retardant. In reality, it is a primary precursor chemical used in the synthesis of sarin nerve gas. It is destined for the Israel Institute for Biological Research. But the toxic chemicals are not the only secret this aircraft is hiding. Built into the empennage, the tail section of the 747, are solid metal counterweights designed to prevent the massive plane from tipping backward when fully loaded. Because space is limited in the tail, Boeing needed a material that was incredibly dense. Lead wasn't heavy enough. So, bolted into the airframe of Flight 1862 are 282 kilograms of depleted uranium, U-238. This airplane is a flying radiological and chemical time bomb. But surprisingly, none of this cargo violates international law. It is all properly declared, it is perfectly legal. And terrifyingly, none of this cargo has absolutely anything to do with why this airplane is about to fall out of the sky.
The true danger isn't in the cargo hold. It is outside, hanging directly under the right wing. Let's go back down to the tarmac. While the pilots are running the pre-flight checks, a ground mechanic wearing a high-visibility vest is doing the exterior walk-around. He holds a heavy Maglite flashlight, sweeping the beam over the massive landing gear struts, checking for hydraulic leaks. He walks under the right wing and stops in front of engine number 3. This is a Pratt & Whitney JT9D7J turbofan. It is the size of a school bus. The mechanic shines his light up into the intake cowl, checking the titanium fan blades for bird strikes or foreign object debris. Finding nothing, he walks to the side of the massive steel pylon that connects the engine to the wing. He looks up at the connection joints. Everything looks solid. The bolts are tight, the cowling is secure. He signs off on his clipboard. But he is looking right at the fatal flaw, and he cannot see it. No one could. To understand what is happening, we need to slow down. We need to look past the aluminum skin, past the heavy steel bolts, and dive deep into the microscopic architecture of the metal itself. Remember the fuse pins we talked about? The hollow steel cylinders designed to break if the engine seized? Inside the pylon of engine number 3, there is a titanium fitting called a lug. The mid-spar fuse pin slides perfectly through this lug, holding the immense weight of the engine in place. 15 years earlier, when this specific fuse pin was being manufactured in a machine shop, a lathe carved out the hollow center of the steel cylinder. The cutting tool was slightly worn. As it shaved away the high-strength steel, it left behind a microscopic scratch on the inner bore of the pin, a machining burr. To a human eye, that inside of that pin looked perfectly smooth, but under an electron microscope, that tiny scratch was a jagged canyon. In metallurgy, this is known as a stress riser. When metal is put under immense load, the mechanical stress doesn't distribute evenly if there is a flaw. The stress aggressively concentrates right at the deepest point of that scratch. For 13 years, this 747 has been flying, 45,000 hours in the air. Imagine the sheer physical abuse. Every time Captain Fuchs pushes the throttles to maximum takeoff power, 47,000 pounds of thrust try to tear that engine forward. The titanium lug pulls desperately against the hollow steel fuse pin. The pin bends imperceptibly. Then the plane climbs to 35,000 feet. The outside air temperature plunges to minus 60 degrees Fahrenheit. The steel violently contracts. Hours later, the plane lands in the sweltering heat of Tel Aviv. The metal expands. Thrust reversers are deployed, violently throwing the engine's power backward, ripping the pin in the opposite direction. Heat, freeze, pull, push, expand, contract 10,000 times. Years ago, right at the site of that microscopic machining scratch, the steel molecules finally gave up. A microscopic fatigue crack formed. Over the years, the crack grew. It advanced atom by atom, millimeter by millimeter, creeping through the wall of the hollow pin. As the crack grew, the remaining solid steel had to carry more and more of the load, which only made the crack grow faster. By the evening of October 4th, 1992, the crack in the mid-spar fuse pin of engine number 3 is exactly 0.05 inches deep. It has carved its way through more than half of the pin's wall thickness. The steel is hanging on by a thread. And this is where the system, the bureaucratic corporate system, becomes the villain. Boeing knew about metal fatigue. They knew these pins took a beating. The maintenance manual strictly required airline mechanics to inspect these pins for cracks. But look at the hubris of the manual's wording. The manual demanded a visual inspection. How exactly does a mechanic visually inspect a crack that is growing on the inside bore of a hollow steel pin, which is completely encased inside a solid titanium lug, which is covered by an aluminum pylon cowling? The answer is, you don't. You can't. To actually find this crack, you would need to haul the massive aircraft into a hangar, build specialized scaffolding, use a heavy crane to physically support the 4-ton engine, completely remove the pylon cowling, unbolt the massive titanium lug, physically hammer the steel pin out of its housing, and then run a specialized ultrasonic probe inside the hollow bore. That process takes days. It costs tens of thousands of dollars in lost flight time and labor. So, the corporate engineers compromised. They decided that ultrasonic testing wasn't mandatory for this specific pin at this specific interval. A flashlight beam on the outside of the painted cowling was deemed sufficient by the regulatory agencies. The beam counters saved their money. The airline maintained its tight flight schedule. And because of that paperwork compromise, Captain Fuchs, First Officer Ohad, and Flight Engineer Sofer are now trapped in a doomed machine. At 6:20 p.m., the massive cargo doors of Flight 1862 slam shut and lock. The hydraulic seals engage. Ship hole clearance, LL 1862 Heavy. We are fully loaded, requesting pushback and engine start. IFR to Tel Aviv. LL 1862 Heavy, ship hole clearance. You are cleared for pushback. Expect runway 01 left. Deep inside the wings, the heavy fuel pumps whine to life. Jet A1 fuel rushes through the lines. Beneath the right wing, the massive fan blades of engine number 3 begin to slowly rotate. A heavy, resonant rumble shakes the tarmac as the igniters fire, and the compressed fuel explodes into life. The vibration travels up the pylon directly into the titanium lug and settles into the fractured, dying steel of the mid-spar fuse pin. The trap is perfectly set. The explosive physics are locked in place. All that is required now is for the pilots to push the throttles forward.
Let me put you in the jump seat, directly behind Captain Yitzhak Fuchs. It is 6:22 p.m. Flight 1862 is lined up on ship holes runway 01 left. The windshield wipers are off, but a light misty rain is streaking the glass. Ahead of you, the runway lights stretch out into the gray Dutch twilight. Captain Fuchs rests his right hand on the 4 massive throttle levers. "Takeoff thrust," Fuchs says, his voice calm, mechanical. He pushes the levers forward. You feel it in your chest before you hear it. The 4 Pratt & Whitney engines spool up, consuming hundreds of gallons of Jet A1 fuel every minute. The noise builds into a deafening, bone-rattling roar. Almost 750,000 pounds of heavily laden aircraft begin to roll. 80 knots, First Officer Ohad calls out, his eyes glued to the airspeed indicator. The runway lines blur. The vibration traveling up through the landing gear is violent. V1, Ohad barks, the point of no return. They are moving at 150 knots. Even if an engine explodes right now, they have to take it into the air. There isn't enough runway left to stop. Rotate. Fuchs pulls back firmly on the yoke. The nose lifts. The massive hydraulic landing gear struts extend, and the 747 rips itself away from the earth, tearing a hole in the low cloud cover. For the next 5 minutes, everything is perfectly, terrifyingly normal. They are climbing on a standard departure route, banking to the right, heading southeast toward Germany. They pass through 6,000 feet. The airspeed is a steady 258 knots, nearly 300 miles per hour. Now, I want you to step outside the cockpit. Slow down time. I want you to leave the crew behind and travel 30 feet down the right wing, right to the pylon holding engine number 3. The ambient air temperature outside is hovering near freezing. The engines are running at maximum continuous climb thrust. That means engine number 3 is currently generating 47,000 pounds of forward propulsion. Inside the titanium lug, the mid-spar fuse pin is screaming. The microscopic crack we talked about, the one that is exactly 0.05 inches deep, is currently taking the entire brutal force of that climb. The high-strength steel is being stretched to its absolute physical limit. The molecular bonds are tearing. Boeing engineers calculated that this steel could withstand an ultimate tensile strength of around 180,000 pounds per square inch. But because of the crack, the stress is no longer distributed. It is entirely concentrated on a surface area the size of a pinhead. At exactly 6:27 p.m. and 30 seconds, as the aircraft crosses over the dark waters of Guimere Lake, the steel surrenders. Snap! The mid-spar fuse pin shears completely in half. In a fraction of a millisecond, the physical anchor holding the back half of the 4-ton engine to the wing is gone. Now remember the hubris of the boardroom. Remember the engineering guarantee. If the pin breaks, the engine drops cleanly away. Here is the exact moment physics punishes that arrogant assumption. Engine number 3 does not drop. How could it? It is still running at maximum thrust. It is still producing 47,000 pounds of forward propulsion. With the rear anchor gone, the immense forward thrust has nowhere to go but up. The front mounts of the engine act like a hinge. The engine violently pivots upward and outward, instantly transforming the massive steel pylon into a giant crowbar. Think about the sheer violence of that. A 9,000-pound jet engine running at full power uses its own thrust to rip itself off the wing. As it violently twists to the right, it shatters the forward fuse pins. Engine number 3 is now completely detached from Flight 1862. But it doesn't fall into the lake, it flies. Propelled by its own dying thrust and caught in the 300-mile-per-hour aerodynamic slipstream of the 747, engine number 3 surges forward and banking sharply to the right. It becomes a 9,000-pound bowling ball.
Waiting directly in its path, just a few yards outboard on the same wing, is engine number 4. The collision is apocalyptic. Engine number 3 slams directly into the cowling of engine number 4. The impact instantly shatters the mounting pylons of the outboard engine. In less than 2 seconds, both engines, a combined 17,200 pounds of titanium, steel, and spinning turbine blades, are ripped cleanly off the right wing. They plummet like meteors toward the black water of Guimere Lake. If this were the end of the mechanical failure, Flight 1862 might have survived. A 747 is designed to fly on 2 engines. Captain Fuchs is a veteran. He could have trimmed the rudder, stabilized the aircraft, and limped back to shiphole. But the system wasn't done failing. When engine number 3 twisted upward and ripped itself away, the steel pylon didn't just break the mounts. The crowbar effect tore a massive 30-foot chunk out of the right wing's leading edge. It ripped out the Kevlar composite panels. It shattered the aluminum skin. More fatally, it severed the internal arteries of the aircraft. Running right through the leading edge of that wing were the heavy hydraulic lines for System 3 and System 4. When the wing tore open, those reinforced hoses snapped like dry twigs. Highly pressurized, corrosive Skydrol hydraulic fluid began violently spraying into the atmosphere at 3,000 pounds per square inch. And right next to the hydraulic lines were the pneumatic ducts, massive pipes bleeding 500-degree pressurized air from the engines to power the plane's internal systems. Those pipes were sheared wide open. Back in the cockpit, the crew has absolutely no idea what has just happened. You cannot see the engines from the flight deck of a 747. For Captain Fuchs, First Officer Ohad, and Flight Engineer Sofer, the disaster announces itself with a concussive, explosive double bang that physically shakes the entire aircraft. Instantly, the nose of the 747 violently yaws to the right. Fuchs is thrown against his shoulder harness. He grabs the yoke with both hands, his knuckles turning white as he instinctively stomps down on the left rudder pedal to counteract the violent rightward drift. "What was that?" Ohad yells, his voice spiking an octave as he reaches for the control column to help his captain. Before Fuchs can answer, the cockpit turns into a sensory nightmare. The master caution alarm begins to shriek, a piercing rhythmic wail. The caution panel lights up with a cascade of amber and red warnings. Flight Engineer Sofer's eyes dart across his massive panel of dials and switches. The needles on his engine gauges for numbers 3 and 4 are spooling down to 0.
"We've lost thrust," Sofer shouts over the blaring alarms. "Engine 3 is winding down, Engine 4 is gone." "Fire?" Fuchs demands, still wrestling with the heavy yoke. The controls feel sluggish, like he's dragging the plane through wet concrete. "No fire warning," Sofer replies, his hands flying across the panel, trying to open the crossfeed valves. "But we have hydraulic systems 3 and 4 losing pressure. We are bleeding fluid fast." "Shiphole approach, LL-1862. Mayday, 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 we have an emergency." "Shiphole approach, LL-1862. Go ahead," the air traffic controller responds, his voice instantly dropping into a grave, serious register. "We have lost engine number 3 and number 4. Request immediate return to Shiphole." In the cockpit, they believe they have suffered a double engine failure. It is a dire emergency, but it is a scenario they have practiced in the simulator a dozen times. You secure the dead engines, you manage your airspeed, and you fly the plane home on the 2 good engines in the left wing. But Captain Fuchs doesn't know the truth. He doesn't know the engines aren't just dead, they are physically gone, sitting at the bottom of a lake. He doesn't know that he's leaking his precious hydraulic fluid into the night sky. Most importantly, he doesn't know that the right wing of his aircraft is missing 30 feet of its leading edge. He doesn't know the aerodynamic profile of that wing is completely destroyed. Right now, moving at nearly 300 miles per hour, the sheer speed of the aircraft is forcing enough air over the mangled right wing to keep it generating lift. Speed is the only thing keeping them alive. But to land at Shiphole, Captain Fuchs is going to have to slow down. And the moment he pulls those throttles back, the physics of disaster will spring the final, fatal trap. Think about the profound terror of fighting an enemy you cannot see. In the cockpit of LL-1862, Captain Yitzhak Fuchs, First Officer Arnon Ohad, and Flight Engineer Gedalia Sofer are engaged in a brutal, physical brawl with a 300,000-pound machine. But the fight is entirely asymmetrical. The crew is operating under an illusion, a fatal misunderstanding of the physics currently tearing their aircraft apart. It is 6:28 p.m. They're at 6,000 feet, banking heavily to the right, flying a wide, desperate arc over the dark Dutch countryside, trying to limp back to Schiphol Airport. Put your hands on the yoke with Captain Fuchs. The control column feels like it is embedded in concrete. The 747 wants to violently roll to the right, pulled by the massive drag of the shredded right wing and pushed by the uneven thrust of the 2 remaining engines on the left wing. Fuchs has his left leg fully extended, stomping on the rudder pedal, physically forcing the massive tail fin to counteract the spin. "Schiphol approach, LL-1862. Ohad's voice crackles over the radio, tight with adrenaline. "We need runway 27. We have lost number 3 and number 4 engines. We are losing hydraulic fluid." "LL-1862, Schiphol approach. Cleared for runway 27. Turn right, heading 260. Descend to 2,000 feet." In the air traffic control tower at Schiphol, the controller is looking at a green radar blip. He has no idea what is happening in that cockpit. He assumes this is a standard, albeit severe, emergency, a double engine failure. You turn him around, you give him the longest runway, and you get the fire trucks rolling. "We are turning right, heading 260, Ohad confirms, his eyes darting between the artificial horizon and the airspeed indicator. But behind the pilots, Flight Engineer Sofer is fighting a losing battle at his massive control panel. The 747 relies on 4 independent, heavily pressurized hydraulic systems to move its massive control surfaces: the ailerons, the elevators, the rudder, the flaps. It is the lifeblood of the aircraft. "Hydraulic systems 3 and 4 are gone," Sofer shouts over the cacophony of alarms still blaring in the background. His hands fly across the switches, trying to isolate the leaks, trying to save the remaining pressure. "They're bleeding out, pressure's at 0. This is the cascading failure. When engine number 3 ripped itself off the wing, it didn't just take the engines, it took the hydraulic lines that powered the leading edge slats on the right wing. This is the aerodynamic trap I told you about, and you need to understand exactly how it works to understand why Flight 1862 was doomed the moment the fuse pin snapped. When a massive airliner wants to take off or land, it has to fly relatively slowly, but a 747 is heavy and its wings are swept back for high-speed cruising. To fly slowly without falling out of the sky, the wings need help. They need to artificially change their shape to generate more lift at lower speeds. They do this using flaps on the back of the wing and slats on the front of the wing.
When a pilot commands the flaps to deploy, these massive metal panels extend outward and downward, increasing the surface area and the curvature of the wing. They physically scoop more air, allowing the plane to fly at 160 knots without stalling. But on the right wing of LL-1862, the hydraulic lines that power the outboard trailing edge flaps and the leading edge slats have been severed. They are dead metal. Captain Fuchs doesn't know this. He has no warning light telling him his right wing is aerodynamically mangled. All he knows is the plane is incredibly difficult to control and that he needs to get it on the ground fast. Flaps 1, Fuchs commands, his knuckles white on the yoke. He needs to start slowing the massive freighter down for the approach to runway 27. Flaps 1, Ohad confirms, reaching down and pulling the heavy flap lever back 1 notch. On the left wing, the hydraulic systems are perfectly fine. The massive Fowler flaps whine as they deploy downward, instantly generating a massive amount of lift on the left side of the aircraft. But on the right wing, nothing happens. The outboard flaps remain stubbornly retracted, dead and useless. The leading edge is a jagged 30-foot crater of torn metal, generating massive aerodynamic drag and almost no lift. This creates a terrifying asymmetric imbalance. The left wing is suddenly generating far more lift than the right wing. The 747 violently lurches, the right wing dropping sharply. Fuchs curses, hauling back on the yoke, stomping harder on the left rudder pedal, physically fighting the plane's sudden urge to roll over onto its back. "We have a massive control problem," Fuchs shouts, his breathing heavy. "It wants to roll right." "Speed is 260 knots, Ohad calls out, his eyes glued to the airspeed tape. "We are descending through 4,000. Because they are flying so fast, the sheer velocity of the air rushing over the mangled right wing is barely generating enough lift to keep it flying. Speed is their only savior. As long as they stay fast, they stay alive. But you cannot land a 747 at 260 knots. The tires would explode. The landing gear would collapse. They would overshoot the runway and plow into the highways beyond the airport. "Schiphol approach, LL-1862, Ohad transmits again. "We have control problems. We need a longer final approach. We need to circle." LL-1862, understand. Continue your right turn, heading 120, maintain 2000. The controller is trying to help them, vectoring them into a wide circle over the dark city of Amsterdam, giving them time to run their checklists, time to lower their landing gear, time to set their flaps. It is 6:33 p.m. The city lights of Amsterdam are glittering below them through the breaks in the clouds. "Flaps 10, Fuchs commands, his voice ragged. The physical exertion of fighting the yoke is immense. He needs more lift. He needs to slow the massive beast down. "Flaps 10, Ohad echoes, pulling the lever further back. Again, the left wing deploys its massive flaps. Again, the right outboard flaps remain dead. The asymmetric lift becomes violently pronounced. The left wing surges upward, the right wing plunges downward. Fuchs wrestles the yoke all the way to the left stops. He has the control column turned completely sideways, demanding maximum left aileron to counteract the roll. He has the left rudder pedal pushed almost to the floor. He is using every ounce of aerodynamic control the 747 has left just to keep the wings level. He is out of options. He is out of control authority. "Speed is 230 knots, Ohad says, his voice losing its professional calm, edging toward panic. They're entering the trap. Fuchs is caught in an impossible, fatal paradox. If he flies fast enough to keep the mangled right wing generating lift, he cannot land. If he slows down to a survivable landing speed, the right wing will lose all lift and stall, and the plane will roll violently out of control. Gear down, Fuchs commands, desperate to bleed off speed, desperate to prepare for the landing that is now only minutes away. Gear down, Sofer confirms. The massive hydraulic struts groan as they extend into the freezing slipstream. The drag of the landing gear slows the plane even further. "Speed 220 knots, Ohad calls out. The airflow over the torn, bleeding right wing is breaking down. The air can no longer follow the mangled curve of the metal. It's detaching. The lift is dying. "Speed 210 knots, Ohad's voice is frantic now. "Captain, the speed!" At exactly 260 knots, the torn right wing was barely holding on. At 210 knots, it gives up completely.
The aerodynamic stall hits the right wing like a physical blow. It is 6:35 p.m. The cockpit alarm, the dreaded stick shaker, suddenly violently rattles the control columns, vibrating them furiously to warn the pilots that the wings are losing lift. But it is only the right wing that is dying. The left wing, with its fully deployed flaps and 2 roaring engines, is still generating massive, powerful lift. The asymmetric force is now insurmountable. No human pilot, no amount of rudder, no amount of aileron can stop what happens next. The right wing completely drops. Fuchs screams, hauling the yoke left, stomping the rudder, fighting with the desperate strength of a man who knows he is about to die. But the 747 ignores him. The massive aircraft violently snaps into a terrifying, unrecoverable right-hand roll. "Going down!" Ohad screams into the radio, his voice cracking, tearing through the air traffic control frequencies. "LL 1862, going down, going down!" The horizon in the windshield tilts violently, 90 degrees to the right. The dark, sprawling grid of the Bijlmermeer apartment complex fills the entire cockpit window. The cascading failure is complete. The trap has snapped shut. And directly below them, a neighborhood of thousands of people is completely unaware that a 300,000-pound guillotine is dropping out of the sky. Think about the sound of the world ending. It isn't a Hollywood explosion. It isn't a sudden concussive bang followed by silence. It is a sustained, physical tearing of reality. It is 6:35 p.m. and 42 seconds. At the intersection of the Groeneveen and Klein-Kreutberg apartment buildings in the Bijlmermeer, hundreds of people are eating dinner, watching television, or putting their children to bed. The buildings are massive, 11 stories of reinforced concrete, glass, and steel, housing thousands of residents in a dense, interconnected honeycomb. Directly above them, falling out of the low, overcast sky at 260 knots, is a Boeing 747. Inside the cockpit, Captain Yitzhak Fuchs is fighting gravity with a yoke turned entirely sideways, his left leg locked rigidly against the rudder pedal. First Officer Arnon Ohad is screaming "going down" into the radio. The stick shaker is violently rattling the control columns. The master caution alarm is shrieking. The windshield is filled entirely with the gray concrete of the apartment complex, rushing up to meet them. The aircraft is banked at a catastrophic 90 degrees. The right wing is pointing straight down like a dagger. It hits the building exactly at the juncture where the 2 massive apartment blocks meet. The sheer physics of the impact defy comprehension. 330,000 pounds of aluminum, steel, and 20,000 gallons of highly combustible Jet A1 fuel slam into the reinforced concrete at nearly 300 miles per hour. The right wing, already mangled from the engine separation, slices cleanly through the top 5 floors of the Groeneveen building like a colossal scythe. The fuselage follows a fraction of a second later, plowing directly through the center of the complex, obliterating dozens of apartments in a millisecond. The kinetic energy alone is enough to pulverize the concrete into dust, snapping steel rebar like dry twigs. But the kinetic energy is immediately eclipsed by the thermal energy. When the massive fuel tanks in the wings and the fuselage rupture, the atomized aviation fuel mixes with the oxygen in the evening air and the sparks from the tearing metal. The resulting fireball is not an explosion. It is an instantaneous, apocalyptic deflagration. A dome of orange and black fire, 2,000 degrees Fahrenheit, violently erupts from the center of the building. It consumes oxygen so rapidly that it creates a massive vacuum, sucking shattered glass, concrete debris, and burning furniture back into the inferno. The fireball balloons outward, hundreds of feet into the sky, illuminating the entire southeastern edge of Amsterdam in a hellish, artificial daylight. The shockwave shatters windows hundreds of yards away, knocking people flat on their backs in the surrounding courtyards. Let me take you inside the building, into the chaos of the immediate aftermath. Put yourself in the shoes of a 28-year-old mother named Saskia, living on the 3rd floor of the Klein-Kreutberg block, roughly 50 yards from the primary impact zone. She's in her living room when the building violently shudders. The sound is deafening, a grinding, tearing roar, followed immediately by a concussive blast that blows her living room windows completely out of their frames. The sheer force throws her over the sofa and onto the floor. The lights instantly die. The television screen implodes. For 3 seconds, there is only the ringing in her ears and the terrifying sound of the building structurally groaning. Then the heat hits. It rolls through the shattered windows like a physical wave, carrying the thick, choking stench of burning kerosene and pulverized concrete. "Mama!" her 4-year-old daughter screams from the hallway. Saskia scrambles to her feet, coughing violently. The air in her apartment is already filling with thick, acrid black smoke. She grabs her daughter, her heart hammering against her ribs, and stumbles toward the front door. When she yanks the door open and steps into the communal hallway, she stops dead. The hallway to her left simply ceases to exist. Where there should be 30 more yards of corridor leading to the elevators, there is only a gaping, ragged cliff edge. Beyond the edge is a chasm of swirling fire and black smoke. The entire center section of the building, 31 apartments wide and 11 stories high, has been completely eradicated. It looks as though a massive fiery bite has been taken out of the architecture. "We have to use the stairs," Saskia yells, hauling her daughter in the opposite direction, toward the emergency stairwell. The stairwell is a nightmare of panic. Dozens of residents, some bleeding, some barefoot, are surging downward in the pitch black. The air is thick with concrete dust that coats the back of their throats, making every breath a desperate gasp. The smell of aviation fuel is so strong it burns their eyes. Outside, the scale of the disaster is incomprehensible. The courtyard between the buildings is a jagged landscape of burning wreckage. Massive chunks of the 747, twisted landing gear struts, shredded aluminum skin, and burning cargo pallets are scattered among the shattered concrete and crushed cars. And then the sirens begin. Within 4 minutes of the impact, the first fire engines from the Amsterdam Fire Brigade arrive on the scene. The firefighters leap from their rigs, hauling hoses and heavy rescue gear, but they freeze as they take in the sheer magnitude of the inferno. They're trained for apartment fires. They're trained for multi-vehicle collisions. They are not trained for a commercial airliner annihilating a 10-story residential complex. "Command, we have a massive structure fire," the lead captain radios, his voice tight. "A major aircraft has impacted the Groeneveen complex. We need every available unit in the city, now." The fire is burning with terrifying intensity, fueled by the thousands of gallons of jet fuel cascading down the remains of the building, igniting everything it touches. The heat is so intense that the firefighters cannot get within 50 yards of the primary impact crater. The water from their hoses is instantly turning to steam before it even hits the flames. "We need to evacuate the surrounding blocks," a lieutenant shouts over the roar of the fire. "The structure is compromised. The remaining sections could collapse." Police officers and firefighters begin sprinting into the surviving sections of the building, kicking down doors, dragging out residents who are paralyzed by shock or trapped by debris. But for the dozens of people whose apartments were directly in the path of the aircraft, there is no rescue. There is no desperate fight for survival. The impact and the 2,000-degree fireball were instantaneous. Captain Yitzhak Fuchs, First Officer Arnon Ohad, Flight Engineer Gedalia Sofer, and the single passenger, a woman married to an El Al employee, are dead. And on the ground, the death toll is entirely unknown. The Bijlmermeer is a diverse neighborhood, home to thousands of immigrants from Suriname, the Antilles, and Ghana. Many of the residents are undocumented. There is no accurate census. The authorities have no idea how many people were inside those apartments when the plane hit. As the night grinds on, the rescue operation turns into a grueling, horrific recovery mission. Hundreds of firefighters battle the massive blaze for hours, slowly beating back the flames with foam and high-pressure water cannons. The smell of the disaster, the toxic mix of burning jet fuel, melting plastic, and scorched concrete hangs heavy over the city. By dawn on Monday morning, the true scale of the devastation is revealed in the gray light. The smoking, blackened ruins of the apartment complex look like a war zone. A massive V-shaped gouge has been torn through the building. Twisted steel rebar hangs from the jagged edges of the concrete floors like exposed nerves. The wreckage of the 747 is completely indistinguishable from the wreckage of the apartments, melted and fused together in the intense heat. And then the rumors begin. As the firefighters and recovery teams begin the grim task of searching the rubble for remains, a strange unease settles over the operation. The men digging through the debris are covered in toxic soot. They're breathing in the pulverized remnants of the aircraft in the building. They don't know about the depleted uranium in the tail section. They don't know about the 190 liters of DMMP, the sarin gas precursor that was loaded onto the aircraft in Schiphol. The system, the corporate hubris, the microscopic fatigue crack, and the arrogant assumption of a clean break has delivered its final, devastating payload. And the aftermath of this disaster will poison the survivors and the rescuers for decades to come. When the sun finally rose over Amsterdam on Monday morning, the true, agonizing scale of the devastation was laid bare. Officially, 43 people died in the Bijlmermeer disaster, the 3 crew members, the single passenger, and 39 people on the ground. But the locals will tell you the real number is much higher. In a neighborhood heavily populated by undocumented immigrants, countless individuals who were vaporized in that 2,000-degree fireball simply ceased to exist, leaving no paperwork behind to prove they were ever there. But as the firefighters drenched the smoldering concrete, a completely different kind of investigation was launching 20 miles away. Dutch aviation investigators were out on the freezing, choppy waters of Gooimeer Lake. They were dragging heavy sonar equipment across the muddy bottom, looking for the ghosts of Flight 1862. Picture the scene on the deck of the salvage barge. The heavy winches are groaning. Slowly breaking the surface of the dark water is a 9,000-pound Pratt & Whitney turbofan engine. It is dripping with lakeweed and thick black mud. The lead metallurgist steps forward in his heavy coat, wiping the muck away from the massive titanium pylon mount. He clicks on a heavy mag light and shines it directly onto the sheared remains of the mid-spar fuse pin. "Look at this," he says, his voice barely audible over the idling boat engine. He traces his gloved finger over the exposed cross-section of the hollow steel cylinder. There are fatigue striations here, darker metal. This didn't snap all at once. He looks up at his colleagues, the realization settling into his bones like ice. This crack has been growing for years, and it was completely invisible from the outside. This single piece of shattered steel triggered a global panic. The investigators realized the horrifying truth. Boeing's failsafe was a death trap. Every single Boeing 747 flying anywhere in the world at that exact moment, carrying thousands of passengers over oceans and cities, was relying on the exact same hollow steel pins. The Federal Aviation Administration didn't wait. They issued an immediate emergency airworthiness directive. Every 747 in the global fleet had to be physically grounded. The airlines were forced to rip the pylons apart, remove the pins, and subject them to rigorous ultrasonic testing. What they found was terrifying. They found dozens of other fuse pins in the global fleet that were already cracking. Dozens of other microscopic stress fractures ticking down like stopwatches. If LL 1862 hadn't fallen out of the sky, another jumbo jet inevitably would have. Boeing was forced to completely redesign the engine mounts. The hollow fuse pin concept was entirely scrapped. They introduced a solid stainless steel pin design with a secondary fail-safe backup system. They mandated that even if an engine seized, it must remain attached to the wing at all costs. The era of the clean break hubris was permanently over. But while the aviation industry fixed its machines, the people of the Bijlmermeer were left to rot. Remember the secret cargo? The 190 liters of DMMP and the 282 kilograms of depleted uranium? When Flight 1862 was pulverized, those materials didn't just vanish. The intense deflagration burned the depleted uranium into a fine radioactive oxide dust. The sarin gas precursor chemicals were vaporized into the smoke plume. In the months and years following the crash, a dark epidemic swept through the survivors, the firefighters, and the recovery workers. Hundreds of people began reporting identical, crippling symptoms: chronic fatigue, severe respiratory issues, neurological tremors, and mysterious skin lesions. They called it Bilmer syndrome. And here is where the system played the villain one last time. For years, the Dutch government and El Al Airlines stonewalled the residents. They insisted the cargo was harmless. They claimed the uranium counterweights were recovered intact, only to admit years later that nearly half of the radioactive material was permanently missing, blown out over the city in the smoke. The corporate machine protected its spreadsheets, while the men and women who breathed in the pulverized remains of a Boeing 747 were told their sickness was all in their heads. The physical scar in the Bijlmermeer has since been cleared. A quiet memorial of trees and water now sits where the Groeneveen building once stood. But the invisible scars, the bureaucratic betrayal, the poisoned lungs, and the sheer terror of that falling Leviathan will never be erased. The truth of what happened to LL 1862 wasn't handed over willingly. It took years of relentless forensic analysis, dredging the bottom of lakes and fighting corporate cover-ups to finally expose the microscopic failures that doomed an entire apartment complex. And that relentless pursuit of the truth is exactly what we do here on this channel. If you want to keep diving deep into the darkest, most complex engineering disasters in history, hit the like button. It tells the algorithm that real, detailed storytelling still matters. Subscribe to the channel so you never miss a case file. And drop a comment below. What do you think was the greatest failure here? The engineering arrogance of the fuse pin, or the bureaucratic cover-up of the toxic cargo? For those of you who want to go even deeper and actively support these intense, long-form investigations, consider becoming a channel member. We have 2 tiers designed for our most dedicated viewers. You can join as an investigator, which directly helps the exhaustive research, archival digging, and forensic deep dives required to build these documentaries. Or if you want to be on the inside, step up to the forensic analyst tier. You'll get exclusive behind-the-scenes access to how we break down these massive engineering reports, early access to upcoming scripts, and a direct line to help choose which disaster we investigate next. The system wants to bury the details. Let's keep digging them up. Click the join button below, and I'll see you in the next investigation.